Hi students, this is Alex here. In this video, we are going to reduce a given matrix A to the diagonal form. As a first part, we have to write the characteristic equation, which is determinant of A minus lambda I equal to 0. Now we are going to write the determinant A minus lambda I. The elements are minus 1 minus lambda, 2 minus 2, 1, 2 minus lambda, 1, minus 1 minus 1, 0 minus lambda, and this determinant value equal to 0. We are going to expand this determinant. So we take the first element and we have to multiply these two, that is 2 minus lambda into minus lambda, and minus of product of this is minus 1, so we make this as plus 1. Then we have to take the second element with minus sign, so minus 2. Then we have to multiply these two, which is minus lambda. Then minus of product of these two will be minus 1. So we make this as plus 1. In the last element, minus 2 into product of this is minus 1. Then this is already minus, so we make this as plus, and it will become 2 minus lambda equal to 0. We are going to simplify further. So this is minus 1 minus lambda. Then we have minus lambda, we have to multiply. So minus 2 lambda plus lambda square plus 1. If we multiply minus 2 inside, plus 2 lambda minus 2. And these two combined, we get 1. We have to multiply with minus 2. So minus 2, then plus 2 lambda equal to 0. Now again, we have to multiply this minus 1 inside. So it becomes 2 lambda minus lambda square minus 1. Then multiply minus lambda, it will become plus 2 lambda square minus lambda cube minus lambda. Then we can make this as 4 lambda, then minus 4. We combine 2 lambda and minus 2 minus 2. Totally it is 0. Let's rearrange. First we write the lambda cube term, so minus lambda cube. Apart from this, we have lambda square in these two places. When we combine, it will become plus lambda square. Then when I am combining the lambda term, we have 2 lambda, then we have minus lambda, then 4 lambda. So 2 minus 1, which is plus 1, then plus 4 lambda gives plus 5 lambda. Then the constants at the end, we have to write it as minus 1, then minus 4. Totally this is minus 5 equal to 0. Now let's change the sign throughout. So this is lambda cube minus lambda square minus 5 lambda plus 5 equal to 0. Now we can take the common terms from the first two term and the last two terms. So from the first two term, lambda square is common, so which is lambda minus 1. From the last two term, minus 5 is common, so lambda minus 1 equal to 0. Now we can take lambda minus 1 factor common. We have lambda square minus 5 equal to 0. Now equating each factor to 0 separately, lambda minus 1 equal to 0, then lambda square minus 5 equal to 0. From the first factor, we get lambda as 1. From the second factor, lambda square is 5. It means lambda value is plus or minus root 5. So totally the lambda values are 1 plus root 5 and minus root 5. So we got the eigenvalues. The eigenvalues are 1, root 5 and minus root 5. Now we are going to find the eigenvector for each eigenvalues. Let's take capital X1, which is X1, X2, X3 be the eigenvector corresponding to the eigenvalue lambda equal to 1. Now we have to write A minus lambda I matrix into x1 equal to 0. Now a minus lambda I we have to take from this, but we have to write it here in the matrix form. So we have copied the elements and we have to put a matrix into x1. x1 is x1, x2, x3 and equal to 0. Now we have to substitute the value of lambda as 1. So the first element will be minus 1, minus 1. So minus 2, then 2, then minus 2. Then this is 1, 2 minus 1, which is 1. Then here it is 1. Then minus 1, minus 1. When I put 1 here, it will be minus 1. So we got the matrix. We are going to multiply this with the column matrix x1, x2 and x3, which is equal to 0. Now we take the first row in the first matrix and first column in the second matrix and multiply the corresponding elements. So we get minus 2x1 plus 2x2 minus 2x3 equal to 0. Then we take the second row and multiply with the corresponding elements. So x1 plus x2 plus x3 equal to 0. Then third, minus x1 minus x2 minus x3 equal to 0. Now we take the first two equations and use a cross multiplication method to find the values of x1, x2 and x3. So we write x1 by, write the coefficient of x2, which is 2 and 1 minus 2 and 1, and put as a determinant. Then x2 by, write the coefficient of x2, then x1. When we are taking x1, we write the coefficient of x1. Sorry, when we take x1, we write the coefficient of x2 and x3. When we take x2, we write the coefficient of x3 and x1. And when we take x3, we take the coefficient of x1 and x2. Now we have to evaluate this determinant, which is x1 by 2 minus of minus 2 plus 2. Then x2 by minus 2 plus 2. Then x3 by minus 2 minus 2. Totally we get x1 by 4, x2 by 0, x3 by minus 4. When we reduce to the simplest ratio, we get x1 by 1, x2 by 0, x3 by minus 1. Therefore, the eigenvector is 1, 0, minus 1. Now we are going to take x2. Let x2 equal to, having the elements x1, x2, x3 be the eigenvector corresponding to the eigenvalue lambda equal to root 5. So once again we write A minus lambda I matrix product with x2 equal to 0, and these are the elements of the matrix A minus lambda I, and we have to multiply this with x1, x2, x3, which is equal to 0. Now again, as usual, we take the value of lambda and substitute in this matrix, that is lambda equal to root 5. So the first element will be minus 1 minus root 5, then 2 minus 2, 1, 2 minus root 5, 1, then minus 1 minus 1, 0 minus root 5. So we have this matrix and we have to multiply this with x1, x2, x3 and equate to 0. Now we take the first row and multiply the corresponding elements of the first column. So we get minus 1 minus root 5 into x1 plus 2x2 minus 2x3 equal to 0. Then second row if you multiply x1 plus 2 minus root 5 into x2 plus x3 equal to 0, and third row use minus x1 minus x2 minus root 5 x3 equal to 0. We are going to take any two equation. Let's take the second and third, which will be somewhat better because first equation and second equation both are having minus 1 minus root 5, then 2 minus root 5, but here there is only one term, that is the coefficient of x2 is having two terms, 2 minus root 5. Otherwise the rest of the terms are having one number as a coefficient. So I am taking the second and third. We are going to use the cross multiplication method. So x1 by, we have to write the coefficient of x2, then x3, which is equal to x2 by, write the coefficient of x3, then x1, which is equal to x3 by coefficient of x1, then x2. So we have to evaluate these determinants. Now the first part, x1 by, we have to multiply these two, so minus 2 root 5 plus root 5 into root 5 is 5, minus or minus plus 1. Then the second part is minus 1 plus root 5. And the third part is minus 1, when I multiply this it will become plus. So plus 2 minus root 5. So totally x1 by, this is 2. So we take minus 2 root 5 plus 6, and here it is x2 by minus 1 plus root 5, and here x3 by, this is 1 minus root 5. So we can see a common term in second part and third part. Let's rewrite this once again, that is x1 by minus 2 root 5 plus 6, and here we will take root 5 minus 1, and here x3 by, if I take minus common I get root 5 minus 1. So we can see the common term root 5 minus 1. So what we have to do is, we are going to divide every term by root 5 minus 1. So even here root 5 minus 1. So while dividing we can cancel these two. So these two gets cancelled, it will become 1, this will become minus 1. But here we have to simplify this. So we'll multiply with its conjugate, which is root 5 plus 1 in both numerator and denominator. Now coming to the simplification, x1 by, so the denominator is a plus b into a minus b, so a square minus b square. But here we have to expand everything. So minus 2 root 5 into root 5 is minus 2 into 5. Then minus 2 root 5. We have to multiply 6 with root 5. So plus 6 root 5, then plus 6, which is equal to x2 by 1, and this is x3 by minus 1. Now coming to the first term once again, x1 by, here we can combine these two numbers, that is this is minus 10 and 6. Before that let's combine these two. 6 root 5 minus 2 root 5 is 4 root 5, then 6 minus 10, which is minus 4, divided by 4, and here it is x2 by 1 and x3 by 1. Finally from the first part, if I take 4 common, we get root 5 minus 1 by 4. We can cancel this, and now we get the values of x1, x2 and x3. So we write the eigenvector x2. First element is root 5 minus 1, then 1, then 1. So we got the eigenvector x2 corresponding to the eigenvalue lambda equal to root 5. And here there is a minus sign. So we have to include that minus sign here. So root 5 minus 1, 1 and minus 1. Then we have to take x3. Let x3 whose elements are small x1, small x2 and small x3 be the eigenvector corresponding to the eigenvalue. We have the another eigenvalue lambda equal to minus root 5. So we have to take A minus lambda I matrix into x3 equal to 0, and we have copied A minus lambda I matrix here into x3. x3 is x1, x2, x3, which is equal to 0. Now we have to substitute the value of lambda as minus root 5. So first element is minus 1 plus root 5, because there is a minus sign, minus lambda, so it become plus. Then 2 minus 2, 1, 2 plus root 5, 1, minus 1, minus 1, and this will become already minus lambda, so it will become only root 5. So we take the matrix, and the next column matrix we have x1, x2, x3, which is equal to 0. Now we have to multiply again by the usual procedure. We take the first row and multiply with the first column all the corresponding elements with three equations. One is minus 1 plus root 5 into x1 plus 2x2 minus 2x3 equal to 0. Then x1 plus 2 plus root 5 into x2 plus x3 equal to 0. Then minus x1 minus x2 plus root 5 x3 equal to 0. Here also once again let's take the second and third equation and solve by cross multiplication method. So we have to take x1 divided by coefficient of x2 and coefficient of x3. So we get 1 and root 5. So this determinant, which is equal to x2 by, we have to take the coefficient of x3 and x1. Then we have to take x3, we have to take the coefficient of x1 and x2. Now we have to evaluate this determinant. The first part is x1 by 2 root 5 plus 5 plus 1. Then second part is x2 by minus 1 minus root 5, and third part is x3 by minus 1 plus 2 plus root 5. Now rearranging, we get x1 by 2 root 5 plus 6, and this is x2 by, taking minus common, we get root 5 plus 1. Here rearranging, we get root 5 plus 1. Now we can see root 5 plus 1 common in these two. So we are going to divide every term by root 5 plus 1. So when I divide, and the first part we have to multiply by its conjugate, which is root 5 minus 1, and even here I have to multiply by root 5 minus 1. And in the second part and third part we can cancel. Now the first part x1 by, we have to multiply 2 root 5 into root 5, so 2 into 5, which is 10, minus 2 root 5 plus 6 root 5 minus 6. The denominator a plus b into a minus b, a square minus b square, which is 5 minus 1, and second part is minus 1 and third part is plus 1. Now x1 by, we can first write the combination of these two, that is 6 root 5 minus 2 root 5, which is 4 root 5, plus 10 minus 6, which is 4, divided by 5 minus 1, which is 4. And second part and third part as it is. Then we can take 4 common, so root 5 plus 1 by 4. We can cancel these two. Then x2 by minus 1 x3 by 1. So we got the eigenvector x3. The elements are root 5 plus 1 minus 1 plus 1. After getting the eigenvectors x1, x2 and x3, we have to form the transformation matrix P, which is writing the x1 as a first column 1, 0, minus 1, then the x2 in the second column root 5 minus 1, 1 minus 1, then x3 in the third column root 5 plus 1 minus 1 and plus 1. So we got the transformation matrix P. Now the required diagonal matrix D is P inverse A P. So first I have to find what is P inverse. For P inverse, as a first part, we have to find the determinant value of P. The determinant value of P is expanding along the row 1. So we take the first element 1, then we have to multiply 1 into 1, which is 1, minus of this product is 1. So first term is 0. In second term, we have to take negative of that element, then this is 0, then minus of product is 1. Then last element is root 5 plus 1 into 0, then minus of minus 1 plus 1. So totally the first element is 0, second element minus 1, and this minus 1 will become plus. So we left with only root 5 minus 1, and the last element is root 5 plus 1. Totally, after cancelling this, we get 2 root 5, which is not equal to 0. Therefore, P inverse exists. Now we are going to find the cofactors. Next we are going to find the cofactors for each element. So let's write this as a cofactor matrix of P. Now first element, this will be 1 minus 1, so which is 0. Then for second element, we have to take the minus sign. Then this is 0 minus of 1. Then third element plus 0 minus of minus 1 plus 1. Then coming to this minus, we have to multiply this. So root 5 minus 1 into 1, then minus of product of this. So we get root 5 minus 1 plus root 5 plus 1. After cancelling this, we get 2 root 5. So this will be 2 root 5. Coming to the next, this element, we have to make plus 1, then plus root 5 plus 1. Then coming to this element, it's again minus, and we have to take these 4 elements, minus 1 plus root 5 minus 1. Then coming to the last row, we have to take plus, then product of this will be minus root 5 plus 1, then minus root 5 minus 1. So we can cancel these two, we get minus 2 root 5. Then coming to this element, we will take minus and minus 1 and 0. So totally, after the minus, let's open bracket, we have to put minus 1. Then coming to the last element, plus. So this is 1 and another part is 0. So we got the cofactor matrix. Let's simplify this further. The elements are 0, 1, 1, minus 2 root 5, and this is root 5 plus 2, and here it is root 5 minus 2, but there is a minus sign outside. So we make minus root 5, then this is minus 2, so we make this as plus 2. Then last row is minus 2 root 5 plus 1 plus 1. So we got the cofactor matrix. From this, we have to find the adjoint matrix, adjoint of P. We just write the first row as a first column. We are transposing second row as the second column. Then third row as the third column. We got the adjoint of P. Now using the formula, we are going to write the P inverse, which is 1 by determinant of P into adjoint of P. And determinant of P, what we got is 2 root 5. The value of the determinant P is 2 root 5. We are going to substitute here. So this is 2 root 5, and the rest of the elements we have to copy as it is. Now we are going to substitute this in the formula. D equal to P inverse AP. So for P inverse, it is 1 by 2 root 5, and we have to copy this matrix into A. We are taken from the question. Then we have to copy the matrix P. Matrix P elements are, so we copy the matrix P also. Now as a first part, we are going to multiply these two. We usually proceed in this direction. So we have to multiply these two. So here the first part of the matrix should be written as it is. Here we take the first row, and here we take the first column. So we multiply the corresponding elements. So first part will be minus 1 into 1, minus 1, then plus 0, then plus 2. So this is the first element. Then we have to take the first one and multiply the second column. So this will be root 5 minus 1 into minus 1. So minus root 5 plus 1, then plus 2, then again plus 2. Coming to the next part, first row we have to multiply the third column. So again minus root 5 minus 1, then minus 2 minus 2. By multiplying 2 and minus 1, which is minus 2, then minus 2 and 1, minus 2. The same thing, we have to take the second row and multiply with each column corresponding elements. So this will be 1 plus 0 minus 1. Then next will be root 5 minus 1 plus 2 minus 1. Then root 5 plus 1, then minus 2 plus 1. Then in the same way, we have to take the third row and multiply with the each column corresponding elements. So minus 1 plus 0 minus 1. So this is, sorry, last element is 0. First is minus 1, then 0, then 0. Then minus root 5 plus 1, then minus 1. And last part is 0. Again minus root 5 minus 1, then plus 1. Again last part is 0. So we completed the multiplication, and let's simplify all the terms. So the first element will be 2 minus 1, which is 1, and here it is 5. So 5 minus root 5, and here it is minus 5 minus root 5. Then this will be 0, and here 2 and minus 2 we can cancel, only root 5 is remaining. And here 2 and minus 2 we can cancel, only root 5 is remaining. Then here it is minus 1. After cancelling this, we get minus root 5, and after cancelling these two, we get minus root 5. Now we are going to multiply these two matrices. So as usual, we write the numbers outside as it is. Open the matrix. We take the first row and multiply the first column corresponding elements. So first is 0, second is also 0, and third is plus 2 root 5. Then coming to the next part, 0, then minus 10, then plus 10. Then coming to the last part, 0, minus 10, again plus 10. In the same way, let's take the second row and multiply with each column corresponding elements. So 1 plus 0 minus 1. The next is 5 minus root 5. Then here it is root 5 into root 5 is 5, then plus 2 root 5, then minus root 5. Then coming to the third part, minus 5 minus root 5 plus 5 plus 2 root 5, then minus root 5. In the same way, let's take the third row and multiply with each column corresponding elements. So 1 plus 0 minus 1, then 5 minus root 5, then minus 5 plus 2 root 5 minus root 5. Then last part, minus 5 minus root 5, then minus 10 plus 2 root 5 minus root 5. So all the multiplication part is completed. Now let's simplify all the numbers. 1 by 2 root 5 is outside. First element is 2 root 5. Here we can cancel minus 10 plus 10 0, minus 10 plus 10 0, then plus 1 minus 1 0, and plus 1 minus 1 0. So we get 0, 0, and here also 0. Then coming to the middle element, this 5 and 5 we can add together, and these two elements will get cancelled. 2 root 5 and these two combine minus 2 root 5. So totally we get only 5 plus 5, 10. And coming to this, minus 5 plus 5 we can cancel, and minus root 5 minus root 5 is minus 2 root 5, which we can cancel, plus 2 root 5. In the same way, plus 5 minus 5 can cancel, 2 root 5 and minus 2 root 5 we can cancel. So totally this is 0, this is 0. And coming to this, we can cancel minus root 5 minus root 5 is minus 2 root 5. With this we can cancel, and here we left with, actually here a small correction, this is not minus 10. We are multiplying 1 with minus 5 minus root 5, minus 5 minus root 5 we got, and minus root 5 plus 2 with root 5. So it is minus 5 only. So here it is minus 5, and the rest of the terms are right, plus 2 root 5. So after cancelling, here we have only minus 10, minus 5 minus 5. Then every element we have to divide by the outside element 2 root 5. So by dividing we get 1 here, and anyway these two are 0, 0. Now outside we have to calculate, that is 10 by 2 root 5. Let's multiply by its like rationalizing. So root 5 we multiply. Now 10 root 5 in the numerator, denominator 2 into 10. Sorry, 2 into 5. So 5 2s are 10, we can cancel, so we left with only root 5. Same thing here, then 0, 0, and again this is minus 10, so we get minus root 5. So totally we got the diagonal matrix, and we can notice here the elements present in the leading diagonals are the eigenvalues which we got, that is 1, root 5 and minus root 5, and we got it here. The diagonal matrix having elements only in the leading diagonal, and the elements are 1, root 5 and minus root 5. And this completes the reduction of the given matrix to the diagonal form. And this is the required diagonal matrix.